9. Pressure limiting devices. Pressure limiting devices shall be provided on all systems containing more than 20 pounds of refrigerant and operating above atmospheric pressure, and on all water-cooled systems so constructed that the compressor or generator is capable of producing a pressure in excess of the high side design pressure, except water-cooled unit systems containing not more than 3 pounds of a Group 1 refrigerant, providing the operating pressure developed in the system with the water supply shut off does not exceed one-fifth of the ultimate strength of the system, or providing an overload device will stop the action of the compressor before the pressure exceeds one-fifth of the ultimate strength of the system. When required by 9.1, the maximum setting to which a pressure limiting device may readily be set by use of the adjusting means provided shall not exceed the design pressure of the high side of a system, which is not protected by a pressure relief device, or 90% of the setting of the pressure relief device installed on the high side of a system, except as provided in 9.2.1. The pressure limiting device shall stop the action of the pressure imposing element at a pressure no higher than this maximum setting. On system using non-positive displacement compressor, the pressure limiting device may be set at the design pressure of the high side of the system, provided the pressure relief device is 1. Located in the low side, 2. Subject to low side pressure, and 3. There is a permanent relief path between the high side and the low side of the system, unvalved. Pressure limiting devices, when required by 9.1, shall be connected between the pressure imposing element and any stop valve on the discharge side, with no intervening stop valves in the line leading to the pressure limiting device. 10. Pressure relief protection. General. Every refrigerating system shall be protected by a pressure relief device or some other means designed to safely relieve pressure due to fire or other abnormal conditions. In addition, all pressure vessels shall be protected in accordance with the requirements of 10.4. All pressure relief devices, not fusible plugs, shall be direct pressure actuated. Each part of a refrigerating system which can be valved off and which contains one or more pressure vessels having internal diameters greater than 6 inches and containing liquid refrigerant shall be protected by a pressure relief device. Stop valves shall not be located between the means of a pressure relief and the part or parts of the system protected thereby, except when the parallel relief devices mentioned in 10.4.2 are so arranged that only one can be rendered inoperative at a time for testing or repair purposes. All pressure relief devices and fusible plugs shall be connected as nearly as practicable directly to the pressure vessel or other parts of the system protected thereby, above the liquid refrigerant level, and installed so that they are readily accessible for inspection and repair, and so that they cannot be readily rendered inoperative. Fusible plugs may be located above or below the liquid refrigerant level, except on the low side. The seats and disc of a pressure relief devices shall be constructed of suitable material to resist refrigerant corrosion or other chemical action caused by the refrigerant. Seats or disc of cast iron shall not be used. 10.2 Setting of pressure relief devices. Pressure relief valve settings. All pressure relief valves shall be set to start to function at a pressure not to exceed the design pressure of the parts of the system protected. Rupture member setting. All rupture members used in lieu of or in series with a relief valve shall have a nominal rated rupture pressure not to exceed the design pressure of the parts of the system protected. The conditions of application shall conform to the requirements of the Section 8, Division 1 of the ASME Boiler and Pressure Vessel Code. Rupture members installed ahead of the relief valves need not be larger, but shall not be smaller than the relief valve inlet. 10.3. Marking of relief devices and fusible plugs. All pressure relief valves for refrigerant-containing component shall be set and sealed by the manufacturer or on assembler as defined in paragraph UG 136 of Section 8, Division 1 of the ASME Boiler and Pressure Vessel Code. Each pressure relief valve shall be marked by the manufacturer or assembler with the data required in paragraph UG 129A of Section 8, Division 1 of the ASME Boiler and Pressure Vessel Code, except relief valves for system with design pressure of 15 psig or less may be marked by the manufacturer with the pressure setting and capacity. Each rupture member for refrigerant-containing pressure vessels shall be marked with the data required in paragraph UG 129D of Section 8, Division 1 of the ASME Boiler and Pressure Vessel Code. 10.3.3. Fusible plugs shall be marked with the melting temperature in degrees. Pressure vessel protection. 10.4. General. Pressure vessels shall be provided with pressure relief protection in accordance with the rules given in paragraph UG 125 to UG 134 inclusive of Section 8, Division 1 of the ASME Boiler and Pressure Vessel Code, with such additional modifications as are necessary for control of refrigerant. Pressure vessels over 3 cubic feet. Each pressure vessel containing liquid refrigerant with internal gross volume exceeding 3 cubic feet, except as specified in 10.4.4, and which may be shut off by valves from all other parts of a refrigerating system, shall be protected by a pressure relief device having sufficient capacity to prevent the pressure in the pressure vessel from rising more than 10% above the setting of the pressure relief device. Pressure vessels over 3 cubic feet but less than 10 cubic feet under conditions specified in 10.4.2, a single pressure relief device may be used on pressure vessels having less than 10 cubic feet internal gross volume. Pressure vessels of 10 cubic feet internal gross volume or over under conditions specified in 10.4.2. If a pressure relief valve is used, a relief device system consisting of pressure relief valve in parallel with a second pressure relief valve as described in paragraph 10.1.3 shall be provided on pressure vessels having internal gross volume of 10 cubic feet or over. Each pressure relief valve shall have sufficient capacity to prevent the pressure in the pressure vessel from rising more than 10% above the setting of the pressure relief valve. Pressure relief valves discharging into the low side of the system under conditions permitted in 10.4.8.1, a single relief valve, not rupture member of the required relieving capacity, may be used on vessels of 10 cubic feet or over. Pressure relief devices in parallel on large vessels. In cases where large pressure vessels containing liquid refrigerant, except as specified in 10.4.4, require the use of 2 or more pressure relief devices in parallel to obtain the capacity required. The battery of pressure relief devices shall be considered as a unit and thereof as one pressure relief device. Pressure vessels with internal gross volume of 3 cubic feet or less, each pressure vessel having an internal gross volume of 3 cubic feet or less, containing liquid refrigerant, except as specified in 10.4.4, and which may be shut off by valves from all other parts of a refrigerating system, shall be protected by a pressure relief device or fusible plug. Pressure vessels of less than 3 inches inside diameter are exempt from the requirement. Pressure relief devices for pressure vessels used as or as part of the evaporator. Pressure vessels have an internal diameters greater than 6 inches used as or as part of the evaporators, insulated or installed in insulated space, and which may be shut off by valves from all other parts of a refrigerating system shall be protected by a pressure relief device in accordance with the provisions of paragraph 10.4.2 and 10.4.3, except that the provision of paragraph 10.4.2.2 requiring a second parallel pressure relief valve shall not apply. Pressure vessels used as evaporators having internal diameters of 6 inches or less are exempt from pressure relief device requirements. 10.4.5 Required capacity. The minimum required discharge capacity of the pressure relief device or fusible plug for each pressure vessel shall be determined by the following. It says where C equals FDL, C equals minimum required discharge capacity of the relief device in 1 pound of air per minute. D equals outside diameter of the vessel in feet. I equals length of the vessel in feet. F equals factor dependent upon kind of refrigerant. C equals 4.88 FDL, where C equals minimum required discharge capacity of the relief device in kilogram per minute. So that's just for kilograms or meters. Yeah, so we don't have to worry about that. Kind of refrigerant, value of F. Ammonia refrigerant 717 is 0.5. Refrigerants 12, 22, and 500 is 1.6. Refrigerant 502, 503, and refrigerant 13, 13B1, and 14. When on cascade system, the value of F is 2.5. All other refrigerants is 1.0. When one pressure relief device or fusible plug is used to protect more than one pressure vessel, the required capacity should be the sum of the capacities required for each pressure vessel. The rated discharge capacity of a pressure relief valve expressed in pounds of air per minute shall be determined in accordance with paragraph UG 131, section 8 of the ASME boiler and pressure vessel code. All piping fittings between the pressure relief valve and the part of the system it protects shall have at least the area of the pressure relief valve inlet. The rated discharge capacity of a ruptured member or fusible plug discharging to atmosphere under critical flow condition in pound of air per minute shall be determined by the following formulas. C equals 0.8 P1D2. D equals 1.12 divided by C/P2, where C equals rated discharge capacity in pounds of air per minute. D equals smallest of the internal diameter of the inlet pipe, retaining flanges, fusible plug or rupture member in inches. P1 rated pressure PSIG times 1.10 plus 14.7 PSIA. For fusible plugs, P1 equals absolute saturation pressure corresponding to the stamp temperature, melting point of the fusible plug, or the critical pressure of the refrigerant used, whichever is smaller, PSIA. I think I'm gonna end right there. Next thing I'm gonna read is 10.4.8, which is pressure relief devices and fusible plugs.